Hello everyone, my name is Kabir Abdullah and today I'll be presenting on nitrogen pollution at Joshua Tree National Park. So in this presentation I'll explain where nitrogen pollution comes from, what forms it takes, and how it affects both the park ecosystem and nearby communities. By the end, you'll understand how this invincible pollutant changed one of the most iconic desert environments in America. Joshua Tree National Park lies in Southern California, overlapping two deserts, the Mojave and the Colorado. It's famous for its distinctive Joshua trees and dramatic rock formation, but what makes it truly special is its biodiversity. This desert ecosystem is extremely fragile because the soils are naturally nutrient poor. Unfortunately, the park lies downwind of the major metropolitan areas, meaning the pollution from cities and farms can easily drift in. That's what makes nitrogen pollution such a concern here. And this is the map. Uh, so, types of nitrogen pollution found. Nitrogen enters the environment in several reactive forms: nitric oxide, nitrogen dioxide, ammonia, and ammonium. Together, these form compounds like nitric acids and nitrates, which can settle onto plants and soil. Studies have found that high levels of nitric acids and ammonia near the park western boundary, closest, uh, closest to Los Angeles and Coachella Valley. These pollutants act like a fertilizer, which might sound beneficial but actually disrupt the park's natural balance. Most of Joshua Tree nitrogen pollution originates from human activity. Vehicle emissions from highways and urban centers release nitrogen oxides, while agriculture and livestock operations emit large amounts of ammonia. Wind carry these pollutants eastward and they eventually settle on the desert surface through a process called dry deposition. Essentially, the park is being fertilized by air blowing of southern California industrial and agricultural regions. So, this slide shows the basic pathway of nitrogen pollution. Emissions from vehicles and farms rise into the atmosphere and also transports eastward by wind, and then return to the earth as deposition. Once the nitrogen lands on the soil, it enriches the environment, allowing fast growing invasive grasses to thrive. These grasses fill the space between native plants and provide continuous fuel for fires. This chain from emissions to fire is how air pollution can physically reshape and landscapes. Effects on human health. Nitrogen pollution doesn't only harm the environment, it also affects the people. Nitrogen dioxide and nitrate particles contribute to smog, which irritates the lungs and eyes. Fine particles known as PM2.5 can trigger asthma and also cardiovascular diseases. While Joshua Tree visitors are only exposed to short periods, the nearby downwind communities experience this pollution regularly, leading to long term health impacts. Environmental consequences. The ecological impacts are far from visible inside the park. Added nitrogen acts as artificial fertilizer, giving invasive uh, species like red brome and cheatgrass a competitive advantage. These grasses grow thickly, turning patchy desert into continuous fuel beds. When wildfires occur, they burn hotter and more frequently, devastating native shrubs and killing Joshua trees may not take decades to recover. As a result, biodiversity declines and the desert begins to transform into a grassland. Long term and ecological impact. Over time, nitrogen continues to accumulate in the soil, changing its chemistry. This leads to acidification and disrupting the beneficial microbes and reducing native wildflower growth. Pollinators such as bees and butterflies lose their food sources, and entire desert ecosystems become less resilient. Essentially, a process that begins invincibly in the air slowly degrades the soil and the life supports. Nitrogen deposition map. Here we can see the official map uh, that we um, from the National Park Service showing the nitrogen deposition from 2000 and 2002 compared to 2019 and 2021. Even though there has been some improvement, the western part of the park still experiences elevated nitrogen levels, exceeding 6 kilograms per hectare each year. These numbers are far from above from ecological threshold from desert vegetation, meaning that the park remains under chemical stress despite emission reductions. Finally, the studies and the data I have cited from are from the peer-reviewed research and the official U.S. agency reports. These include field studies by Allen and colleagues on nitrogen impacts, national monitoring data from the National Park Service, and the atmospheric modeling from Lee and collaborators. Together, they show how interconnected and our human activities are with delicate ecosystem like Joshua Tree and why managing nitrogen emissions remain essential for preserving our natural parks. Thank you so much. You have a good day.